Hi everyone! Like my video before, I will solve some question and it's about Newton's law of motion. And here we go. Now we have the diagram in here and we just have to find the first equation and the second equation based on the first object and the second object. The resultant force in y coordinate is equals to 0. Then the force in y coordinate are wake force and normal force. We have to see the coordinate lines to get the plus and minus in the equation. And here I got n minus wy equals to 0, which is wy in factor is w cos theta. So I got the equation is n equals to w cos theta. In the resultant force in x coordinate of the first object is mass times acceleration. For the forces are T1 or tension minus Wx minus friction 1 equals to mass times acceleration. Wx in vector is W sin theta. So we got the first tension equals to mass times acceleration plus W sin theta minus friction. We move to the second object. Same like the first object, the resultant force in y coordinate is equals to 0. Then the forces in y coordinate are wake force and normal force. And we got n2 minus wy equals to 0, which is wy is equals to w cos beta. And we got the equation n2 equals to w cos beta. For the resultant force in x coordinate of the second object is mass times acceleration. The forces in x coordinate are tension and wake force. So the final equation is T equals to minus m times a plus w sin beta. Based on the diagram, we know that the tension is same because the root is same too. And we got first tension equals to second tension. So we just have to substitute the first equation and the second equation of tension. So we got first mass times acceleration plus second mass times acceleration equals to second wake sin beta minus first wake sin theta minus friction 1. And we just have to move the mass from the left side to the right side. So we got the acceleration equals to second wake sin beta minus first wake sin theta minus friction 1 over mass first mass plus second mass. I've prepared my second question and just watch. Unlike the first question, to see the first object and the second object and the third object. In the first object, the resultant force in the y-coordinate is 0. So I got normal force equals to wake force. It's quite different from the first question because it has no angle, so we don't have to write the theta or beta. And for the resultant force in x-coordinate, I got the forces is tension and friction. So I got the first tension is equals to mass times acceleration plus friction 1. For the second object, the resultant of y-coordinate is 0, so I got the normal force equals to wake force. And then the forces in x-coordinate is minus second tension plus second friction equals to minus mass times A. So we got the second tension is equals to friction plus mass times acceleration. The tension and the acceleration are negative because the direction on the coordinate line is negative 2. In the third object, we don't have to write the resultant force in x-coordinate because it has no force in x-coordinate, so you just have to write the resultant force in y-coordinate. In the y-coordinate, it has 2 tension and 1 wake force, so we just write tension plus tension minus wake equals to minus mass times acceleration. And we got the third tension is minus mass times acceleration plus third wake minus third tension. Based on the diagram, we know that first tension is equals to third tension and it is equals to second tension, but we have to solve the first question is first tension equals to third tension, and we just have to substitute this, and we got third tension is equals to minus third mass times A plus wake minus mass times A minus friction. And for the second equation is the second tension equals to third tension, but the third tension we used in here is the last equation we just got, and we just have substitute like that. And we will get second mass times acceleration plus third mass times acceleration plus first mass times acceleration equals to minus first friction minus second friction plus third wake. And we move the mass from the left side to the right side, and we got acceleration is equals to third wake minus first friction minus second friction over first mass plus second mass plus third mass. Thank you all for watching this video, and goodbye.